Alright, this morning we're going to talk about the discriminant of a quadratic equation. So, just want to show you how to line this out. So, if you have a quadratic equation, set equal to 0, ax squared plus bx plus c, the general form. The discriminant is what's going to be under the square root in the actual quadratic formula, but it does not include the square root. So, it's going to be b squared minus 4ac. So that's what comes under the square root in your quadratic formula. Okay, so there's three different possibilities that can happen in this situation. And so I want to come down here and kind of show you some examples what it would look like and kind of like what the graph would look like if you were to put it in the coordinate plane to see kind of an image of what it would be. So if the discriminant, if you do that b squared minus 4ac and it's a negative number, okay, let me just give you an example. I'm just going to make something up. So let's say I had like 5 plus or minus the square root of negative 4 over 2. So the negative 4 in that example would be the discriminant. Whoops, sorry guys. Sorry guys. Okay, so in this case what you would end up with, this would be 5 plus or minus 2i over 2, just as our example, and so that would be two different, because you'd have 5 plus 2i divided by 2 and 5 minus 2i divided by 2, so you would have two imaginary solutions in this case, and that's really what you need for the box. The type and the number of solution, the type, they'd both be imaginary, and the number you'd have 2, so this is just a little example. Okay, now if your discriminant is negative and your solutions are imaginary, that means if you had a graph, it'd be something, you know, it could turn right side up, it could turn upside down, but the graph would never touch the x-axis. So if you're touching the x-axis, then you have a real solution. All right, second thing that's a possibility for your discriminant is 0. So again, I'm just going to make up an example here. So let's say I had negative 3 plus or minus the square root. We ended up with 0 as our discriminant. And then maybe on the bottom this was just 2. Well, what's going to happen here, the square root of 0 is just going to be 0. So you still have the negative 3 plus or minus, but if you add 0 or subtract 0, it's the same thing. So the only answer in that situation, my little example I just made up, would be the negative 3 over 2. So this is just one solution, and it's going to be a real solution. Now on a graph, the only time this can happen, and these graphs I'm sketching are not related to the examples I'm writing down specifically. I'm just giving you a sketch. So if this is the case, if this is what happens, then the vertex is going to be, could go up, could go down, but the vertex would be the only point on the graph that would touch the x-axis. That's the only way you could get one solution. Okay, now your last option is if that discriminant's a positive number. So again, I'm just going to make something up. Let's say we have 7 plus or minus, and I'll do something so we have a nice square root. Let's say this was 25 and this was 2. Okay, so the 25 would just represent the discriminant. If you were to actually simplify this, you'd have 7 plus or minus 5 over 2. So if I did 7 plus 5, that'd be 12, divided by 2 would be 6. And if I did 7 minus 5, that'd be 2, divided by 2 would end up being 1. Those are both real numbers. Those would both be the places that that particular example would cross the x-axis. So for the number and type here, you would end up with two real solutions anytime this is a positive value. Now I picked, and in all my examples here, I kind of picked numbers to be the discriminant that had a perfect square. So remember, that doesn't always happen. That could be something that you might have to simplify, or something that might be a nasty decimal if you're trying it on the calculator. But here we go for the graph. So again, it could turn right side up, could turn upside down, but your parabola would cross the graph in two different places. So those are your three options for the discriminant. Okay, so here we're just going to tell the number and type just kind of from our chart above. So just writing this on the screen so you guys can see it again. Now remember, this does not involve the square roots. It's just b squared minus 4ac. So this would be 5 squared minus 4. Now I just have an x squared here, so that a value would be 1, and then the c value would be 10. So here we'd have 25 minus 40, which is going to give you negative 15. Now, it doesn't matter what the number is. I'm not asking you to actually find the solutions. I'm just asking you to tell me the number and type. So if this is negative, if you guys look back up at the chart, negative discriminant means you have two imaginary solutions. So we're going to involve the I. Second example, b squared, this 4 squared, minus 4. A value here is 1, c value here is 4, so b squared minus 4ac. This is 16, this is 16, so the discriminant here is 0. So if you're looking at that table above, that's the one in the middle. So this is the one real solution, and that's the situation where your vertex would touch your x-axis on a graph. And last one here, b squared, 17 squared, 4 times a is negative 8, times c is 10. Now I know this is 289. Let me grab my calculator here for the rest of this real quick, because I don't know that off the top of my head. So I'm going to do, this is minus, so I'm going to do 4 times negative 8 times 10. So now this is going to be then minus a negative 320. So if I do 289 minus a negative would end up being plus. So totally doesn't matter what the number is, it just matters if it's positive, negative, or 0. This particular discriminant's positive, so that means our quadratic would end up with 2 real solutions. Alright, example 2 here is just kind of a different way to ask the question, a little bit more visual, a little bit going with the graph part of the table I gave you guys. So I'm just going to highlight the x-axis on each graph here. And wherever I cross the x-axis with my parabola is going to represent real solution. So in this first graph, since I don't touch the x-axis, this has no real solutions. If your graph does not touch the x-axis, that means the discriminant had to be a negative number. And if it's negative, you have the situation where you have 2 imaginary solutions. If just the vertex touches the x-axis on your graph, just like it does here, this is just going to end up giving me a discriminant of 0, and that has 1 real solution. And the last graph, you can see that I crossed the x-axis in 2 places. So if you have real solutions and you have 2 of them, your discriminant had to be positive, and then you could say 2 real. So the number is the 2, 1, or 2, and then the type is the imaginary or the real. Okay, so finally, down here at the bottom, little application of the discriminant. So this says a baseball player throws a ball upward toward a wall. It's 18 feet tall. So there's the height of the wall there. Trying to get the ball to a fan that's in the baseball stands. Okay, the height h in feet of the ball t seconds after it leaves the player's hand is modeled by this lovely equation here. Explain your answer for each using the discriminant. Okay, so I want to know, will the ball reach these certain heights? So the first question just says, will the ball reach a height of 15 feet? So what we want to do is plug in 15 for h. So just going to use this formula right up here. Negative 16t squared plus 25t plus 6. Okay, so I'm not asking you when, I'm asking you if. So in terms of solving this question, will this ball reach a height of 15 feet? If your discriminant is positive, or if it's 0, that means the graph has a real solution, so that would mean my answer would be yes. If I get a negative discriminant, that's going to have imaginary solutions, so my answer in that case would be no. We're not asking for the time, we're just asking if this is going to happen. So first thing you do want to do is make sure you set the equation equal to 0. So I'm going to need to subtract that 15. So 6 minus 15 there is going to give us negative 9. Okay, once it's set equal to 0, that's when you want to do the discriminant. So my b squared, 25 squared, minus 4 times a times c. And so I'm just going to grab my calculator here really quick. So 25 squared minus 4 times negative 16 times negative 9. And when I plug that in, doesn't matter what the number is, it just matters whether it's positive, negative, or 0. So that guy's positive. So this would have 2 real solutions. So is this going to be able to reach a height of 15 feet? Our answer would be yes, because we have 2 real solutions. Now, this says, will the ball go over the wall? Let me slide this back down just for a second. If you guys remember back in the directions, it said the wall was 18 feet. So we're just going to answer the same question, but this time we're going to substitute in 18 for the height. So it would look like this with the 18 plugged in there. And remember, I'm not asking you at what time does this happen. Then we would go through and use the quadratic formula to figure that out. But I'm asking you, is this possible? So we're just basically checking to see whether or not, this would be negative 12, we're checking to see, does this have real solutions? So your b squared, 25 squared, 4 times a times c. So a is negative 16, c is negative 12. So I'm just going to type that in again. So 4 times negative 16 times negative 12. Now here I got negative 143. Again, this is not the answer. The answer is, how does that answer the question in terms of the discriminant? So this is your discriminant. If this is negative, this has 2 imaginary solutions. So it's not going to be possible for that ball to go over the wall unless we have a real solution. So my answer here would be no.